Now, the next challenge is called Magician. We're given a file called index.html with a text that contains data encoded in different formats, and we have to get a secret out of it. Now, let's open this file in the web browser. So here we see different parts of the text. And if we go back to the raw file, we can see that the first part of it has some unusual characters like ampersand and semicolon here and there. And in the web browser, it is displayed correctly. Now, we don't have to do anything with this part of the text, but this means that the text was encoded in an HTML format to represent special characters in the web browser correctly. Now, what is encoding in general? Encoding is a process of transforming data to a certain format using a special schema. It is a reversible process, meaning that we will be able to go back to the original data. For this challenge, I would recommend using the CyberChief tool that will help us to analyze the data and guess the encoding type. Now, we look at the second part of the text. So we don't know which encoding type it uses. We just see some percent signs followed by the numbers and the percent signs and the numbers again. So there is an operation in CyberChief which is called magic. It helps us to analyze the data and suggest which operations could help to get more sense out of it. Now that's what we need. So we run it against the second part of the text and we got the result of this URL decode. Now, there is a little hint in CyberChief that will help us to learn more about encoding. So if we type URL and then if we choose the URL encode as an operation, it gives us a full description of it. It encodes programmatic characters into percent encoding, a format supported by URIs and URLs. For example, the equal sign becomes %3d. So now, and then here is a link that will help us to learn more about it, but we kind of got the idea of it. So we have the percent sign and we have some special characters after that. And let's try to decode it from URL. And we got the text that makes sense. Now there is a part that might be the part of the secret. Okay. So the next part of the text is this. Now we repeat the same steps with every part. We choose the magic operation. This one will take a while. And we have a result. It's from base 32. Now, if we look closer at this part of the text, we can see that there are some letters followed by a number, and then there are some letters again followed by the number. So CyberChief suggests using from base 32. Now let's read more about base 32. So it's encoding arbitrary byte data using a restricted set of symbols. Okay, so this is what is important for us. It is usually the uppercase alphabet and the numbers 2 to 7. This is a hint that would help us to define the type of encoding from just the first glance. So let's try to decode it. And as we can see, we got the text that would make more sense. and we can see like the small part is the part of the secret. Okay, now let's go to the next one. We repeat the same steps again. Magic, and in this case it suggests from base 64. Now if we look at this part, we can see two equal signs at the end and some uppercase and lowercase letters and some numbers. So let's learn about base 64. So this operation encodes raw data into an ASCII base 64 string. So for example, hello becomes this. So let's try to decode it. Indeed, it is a base 64 encoding, and we can see the part that is probably a part of the secret. Okay, let's go to the next one. Here we can see some numbers and letters. So repeating the same steps. Okay, and this time it gives us the hex from hex operation. Let's try to learn it. About it, it converts the input string to hexadecimal bytes separated by specified delimiter. So we can see the hexadecimal bytes indeed. So let's try to decode it. Okay, and we got the text out of it. Now we'll look at the next part of the text, and we use the same method. We use the magic operation. However, in this case, we do not get a straight recipe that we would use. That's why we will have to investigate by our own. So if we type from to the operations, it will give us all the options that we have in order to decode it. So by already knowing the base 32 and base 64, we can look at this text and define that it's probably not those types of encoding. We know the hex type of encoding as well. Doesn't look like it's using that type as well. So we have the hex dump. This one is not using the hex dumps either. So by looking at this list, we can just try doing random operations and see what is the input, kind of like brute forcing them. But I would recommend looking at these options from char code. So if we do the brute force and we get to the char code, we can see that it converts Unicode characters codes back into text. So we will see the Unicode characters. And if we take a closer look of the initial text, we understand that this is a Unicode representation of the characters that are used in the text. So, and as we can see, we get the secret part of it. So now let's look at the final part. Now the final part of the text is consisted from zeros and ones. So this gives us a hint that it is a binary representation, but let's see what the magic operation gives us. And yes, indeed, it is a binary one. So let's try to, so it displays the input data as a binary string, meaning the two-way style, zeros and ones. So we decode it from binary, and we have a text and the secret, the final part of the secret, is right here. So that was it for this challenge. To get the flag, we just need to combine all parts of the flag, and we get the secret.